Hi guys. So today we're going to look at solving log and exponential equations. For today we're kind of going to stick to the basics and then we're going to look at some more difficult ones next class. So we're going to start with log equations. Typically when we have log equations you're going to see two different styles which will look like one of these first two that we have here. So typically how you're going to want to start these is if you can use your log properties to condense the logs, go ahead and do that. So what I mean by that is using those properties we did last class. So right here, that 2 can become the exponent on the 4. So I can rewrite this as log base 3, 16, minus log base 3 of 2. And then using those same log properties, I can rewrite that as log base 3 of 16 divided by 2, which is 8. Well, at this point, since these logs have the same base, if you have a log equal to another log, the only way these can actually be equal is if the thing in parentheses or if your arguments are the same. So the only way this can possibly work out is if x minus 4 is equal to 8. Now what you technically could do here, algebraically, is say you're doing 3 raised to those powers, then based off those inverse properties, that's how it's going away. You're technically not canceling out the logs. I know it kind of looks like that, but technically that's what we're doing. We're saying it's 3 raised to that power, based off those inverse properties, that's what they're equal. The reality is here is the only way these are going to be the same is if these are the same. So at that point you have a pretty easy equation to solve, and you get x equals 12. Now if you don't have a log equal to a log, you are going to want to try to isolate that log. So if you look at this next one, what we're going to want to do is try and get this natural log here by itself. So what I'm going to do is go ahead and add 7 and divide by 2. So this time, instead of having a log equal to a log, I have a log equal to a number. If you have a log equal to a number, you're going to want to write this in exponential form. So the base of ln is e, so e to the 11 over 2 is equal to 2x minus 1. Then from this point, go ahead and get get x by itself. So I would add 1, and I divide by 2. And I get x. Now at this point, since we don't have a calculator, you would leave it in that form. If you had a calculator, then you can go ahead and find both those find that possible answer. But for now, we're going to leave this in our exact form as if we don't have a calculator. All right, so these next two, we'll go ahead again, use those log properties. If you feel comfortable, pause the video and try these on your own. All right, so using those log properties, I can combine these two together by multiplying the arguments. So this would become x squared plus x minus 2 equals 1. We have a log equal to a number, so I need to rewrite this in exponential form. So 10 to the first is equal to x squared plus x minus 2. So since it's quadratic, let's set it equal to 0. That's going to factor into x plus 4x minus 3. So my two possible answers, and I say possible because just like always, we need to check for extraneous solutions. Now what's going to be the extraneous solution here is negative 4. Because if you remember, you cannot have a negative argument. If I take negative 4 and I plug it back into either of these places, if either one gives me a negative argument, it's an extraneous solution. Negative 4 would make both of them a negative argument, so it's definitely extraneous. It's not the fact that the 4 is negative, it's the fact that when I plug it in, it gives me a negative argument of that log. All right, let's go ahead and try this next one. There's more than one way to work this out. I'm going to go ahead and move that log to the other side. So I'll make this log base 2 of x minus 3 minus log base 2 of 3x plus 1. Now using my log properties, I can condense. That'll give me division in the argument. Now I'll rewrite it in exponential form. So 2 to the third equals x minus 3 over 3x plus 1. So I can multiply both sides by 3x plus 1, or cross multiply, however you want to look at it. So that'll give me 24x plus 8 equals x minus 3. So 23x equals negative 11, and x equals negative 11 over 23. But again, check for extraneous solutions. If I plug that back in, negative 11 over 23 minus 3 is a negative. Since that was the only solution I got, this actually has no solution. And if you think about this graphically, okay, you've got a log graph that's been shifted to the right 3, and then you've got a log graph that's been shifted up 3 and stretched a little bit horizontally. Okay, those two graphs are not going to touch each other. Okay, they are not going to cross. The other way you could have done this if you wanted to It's a little bit different, but you actually could rewrite 3 with log base 2. So a different way you could have done this is log base 2 of x minus 3, and then 3 is the same thing as log base 2 of 8. Then you could have used your log properties to combine those two sides together, and you end up with the exact same thing that you have here, maybe in less steps. But again, you're still going to end up with that same answer. But that's just a different way that you could do that, depending on what makes more sense for you. So now let's look at some exponential equations. So again, we're going to look at 2 different types here. One thing you want to see when you have these exponential equations, if possible, you want to rewrite the bases in terms of the same number. That's going to allow you to actually get an exact answer without a calculator. So what we could do here is rewrite it. Now, you have to be really careful on these. Something like this is one of the most missed questions I see, because what people will do is they'll see, oh, hey, this 3 has a square root, so let's make this 3 to the 1/2. The problem is by doing that, that is not the same thing as what was originally written right here. Okay, it's not the exact same thing. You've now changed the equation. So I have to rewrite this with the same base as opposed to changing the equation. So what that means, I'm going to leave this as 3 to the x minus 1. I'm going to rewrite the square root of 3. The square root of 3 is the same thing as 3 to the 1/2. So at this point, I have not changed the equation in any way. The only thing I did was I rewrote square root of 3 as 3 to the 1/2, and that is all. So now what I can do, using your power to a power, this can become 1/2 times x plus 1. Well, now if the bases are the same, those exponents have to be the same. Now again, you're not really canceling out the 3's. Technically, you're taking log base 3 of both sides to make those go away. But it's going to look like you're canceling out the 3's. Just because in reality, your exponents here will have to be equal in order for these equations to be equal. So to get rid of that fraction, I'll multiply everything by 2. And then I would get that x is equal to 3. We don't have to worry about extraneous solutions on these types of questions. If you get a negative as an exponent, that's okay. Right? Negative as exponents are okay here. All right, let's try this next one. Again, try to rewrite these with the same base. Don't change them, rewrite them. 1 over 9 and 27 can both be written as 3 to the something power. 1 over 9 is 3 to the negative second, and 27 is 3 to the third. Well, now those exponents can get multiplied. So the only way these will be equal is if the exponents are equal. So I get negative 7x equals 3, and x equals negative 3 over 7. Again, that negative is okay because that's not the argument of a log. All right, so now we're going to look at some other exponential equations where it's not a 2 bases that we can write the same. All right, and we'll look at some more of that style with different bases next class, but this one really just has one exponent on here. If you have a base with its exponent, and that's the only one you have, you want to isolate it. Just like we've been doing all year with all the different types of expressions. Get the square root by itself. Get the absolute value by itself. All the different things we've done. Get the log by itself. Our goal here is to get the base by itself. So let's start by getting rid of the plus 1. Well, now the only way to get the exponent out is to rewrite this as a log. So this would become log base 2 of 14 equals x minus 1. So then your last step here would be to add 1, and be careful, it's not going to become log 15, because 14 is the argument of the log. Okay, we can't just add 1 inside the argument. Okay, there's a different thing between that expression and this expression. Okay, those are very different, and we cannot do that. We're not adding it to the log. So since we don't have a calculator, that's our exact answer, and that's how we'll leave it. All right, if you feel comfortable, pause the video, try this one on your own. All right, you want to get the e here by itself because that's your base. So we're going to add 2. We're going to divide by 2. Once that base is by itself, you can rewrite this as a log. Log base e is ln, so ln 3 equals x over 3. Last step to get x by itself would be to multiply by 3 on both sides. And again, since we don't have a calculator, you can leave this here. Now, it's not wrong if you want to write this as the natural log of 27. because again, that 3 can become an exponent. But it's okay if you just leave it here. What we'll probably do on these is write the exact answer and then use the calculator to find what that decimal equivalent is. All right, that's it for today. Again, this is just kind of an intro to solving some of these equations. We'll look at some tougher ones next class.